Hello everyone, welcome back to SimplyCam. My name is Prakash and today we are going to explore the production of propylene glycol using the propylene oxide and H2O. So let's start with component list. First we will add the all three component which is propylene glycol, propylene oxide, propylene glycol and third is water. Next, we will select the fluid package. So, for this problem, we are go- going to use Uniquick as a fluid package. So now go to the binary coefficient. Here we can see only four coefficient are calculated by the Uniquick. So if we want to estimate the other coefficient, first select the Uniquick VLE as a coefficient estimation, then click on the unknowns only and it will automatically calculate these two coefficients. Next, go to the reaction set, add the reaction, add reaction. So select kinetic as a reaction type, click on add reaction. Now double click on it. So add the component. First is H2O, second is propylene oxide, and third is propylene glycol. The stoichiometric coefficient for H2 it will be -1, for oxide it will be -1, and for glycol it will be +1. And for the forward order for H2O, put it as 0. Now come to the basis. So basis will be molar concentration only. Base component will be propylene oxide, and the reaction phase will be combined liquid. Okay. So now enter the value for A, which is 1.7 e to the power 13, and value of E is 1.24 e to the power 4. Yes, BTU LB per mole. So here we can see the reaction is ready. Close it, add to the fluid package, add set to the fluid package. Now go to the simulation. Add to material stream. Name is at water. Temperature is 75 degree Fahrenheit. Pressure is 1 atm. Sorry, the pressure is 1.1 atm. Yes. Now go to the composition. Edit it. Mass flow. LB per hour. Okay. Close it. Now click on the second stream. Name is at propylene oxide. Temperature is 75 degree Fahrenheit. Pressure is 1.1 atm. and the mass flow is 150. Molar flow is 150 lb/mol per hour. Now go to the composition. This is 1, another are 0 because in this stream only propylene oxide is there. Okay. Now add the mixture. Add a mixture. Go to it. Name is that mixture. The inlet is water and propylene oxide. Outlet is mix out, and in the parameter set is to set outlet to lowest inlet. Okay. Now add a CSTR reactor. Go to the reactor. Add a CSTR reactor. Open it. Name is it as reactor. Inlet is mix out. Outlet is reactor vent, and liquid outlet is reactor rods. Energy coolant parameter. Okay. Now go to the reaction. Reaction set is set 1 reaction. Now go to the dynamic. Connection is all good. Parameter is all good. Now go to the dynamic, and the vessel volume is 280 feet cube, and the liquid volume percentage is 85 percentage. Go to the worksheet. First we assume the reactor is worked as a isothermal. So let's assume the temperature of the outlet of the reactor is 75 degree Fahrenheit. Now go to the reaction result. We can see the actual percentage conversion is 40.30. So we want this conversion to at least 90% to 95%. So for that we are going to change the outlet temperature of the reactor product. So first take it as 100. Okay. Some problem is there. Put it as 140. Yeah. Put it as 140. Go to the reaction. Yeah. Here we can see at 140 degree Fahrenheit, the actual percentage conversion is 94.7, which is good. So now close this. Now we are going to add a column. So selected distillation column. Open it. Name is it column. Inlet stream is reactor product. So the stages of the column is by default set is 10. So don't change it. Condenser duty name. Condenser type will be partial. So this is overhead vapor. This is overhead liquid. Regular duty. And from the bottom we will get glycol. Click on next. Click on next. Condenser pressure is 15 psi, regular pressure is 17 psi. Don't change the other things. Click next. Click next. The vapor rate will be 0. Flow basis will be molar. Reflex ratio will be 1. And click done. So now we are going to add a specs. First go to monitor, and we don't know the distillate rate, so deactivate it. Now go to the specs, add a specs, select column component fraction, add specs, name it is at H2O fraction, and the stage will be reboiler. Flow basis is mole fraction, phase will be liquid, specs will be 0.005, and the component is H2O. So the specs is selected. You can go to the monitor, you can see. Now run the column. So the column is converged in the worksheet. We can see in the overhead vapor, the mass flow, molar flow, or in the overhead liquid, we can see molar flow is 475. And if we go to the compositions, we can see from the reactor product, we was getting the H2 is 0.75 and the glycol is 0.2297 and the propylene oxide was 0.0129. Right. From the overhead vapor of the column, we can see the propylene oxide NH2O is coming out, and from the overhead liquid, only H2O is coming out, but in the glycol, only propylene glycol is coming out. So in the overhead vapor of the column, the propylene oxide and H2O is coming out. We can use it as a recycle, and so we can use the overhead vapor as a recycle, connect it to the mixture, so the required quantity of the water and propylene oxide will be less, so it will be beneficial for our production of the propylene glycol. So it is a very easy process. So if you want to change anything, you can change it and do by your own. So thank you for watching this video. Please like it and share it with your friend. Subscribe our channel. If you want any topic or any or production of any chemicals, you can comment. We will try to make video on that. So thank you for watching the video. See you in the next video. Bye bye.